Hi everyone, today we're going to talk about second derivatives. So first off, what is the second derivative? It's just the derivative of the derivative. So our notation is written as f double prime of x. Sometimes you might also see d2y over dx2 or d squared y over dx squared. I'm going to stick to the double prime. Good news is I don't have any new rules for you. The rules that we use for first derivatives work for the second derivative. We're just going to do it twice. So the first one says f of x is 8x minus 4. You know the first derivative, f prime of x, is 8. And then when I take the second derivative, the derivative of 8 is 0. We can only get to the second derivative by knowing the first one, so you do have two sets of things to do, but it's not too bad. Same rules. Our second one says f of x is x squared plus 5x minus 2. So our first derivative, x squared is 2x, plus 5x becomes 5 and the 2 goes away. Now when I go to my second derivative, so f double prime of x, derivative of 2x is 2 and the 5 is gone. So this time we have a number other than 0 left. Let's keep going. G of x is negative 3x squared minus 7x plus 44, so g prime. Negative 3x squared is negative 6x. Negative 7x gives me negative 7 and the 44 is gone. Do it again. So my second derivative is negative 6. Pretty good. Let's make it a little more interesting. Let's add in natural log. First derivative, you know, is 1 over x. With 1 over x, I think I need to rewrite that as x to the negative 1. I like it to be a power, so I can use the power rule. The second derivative, the negative 1 comes down. I have x to the negative 2. I'm going to write that as negative 1 over x squared. Since we did ln, makes sense that we would also look at e. H of x was e to the 5x, h prime of x will be e to the 5x, but don't forget to go back to that 5x and take the derivative, so I have 5e to the 5x. We're going to do that again, h double prime of x. I have 5e to the 5x, derivative of 5x is 5. You do need to simplify that. 5 times 5 is 25, e to the 5x. Now I have f of x is 1/4 of x to the 4th minus 2/3 of x cubed plus 9x minus 7. F prime of x, the 4 cancels the 1/4, I have x cubed. The 3 cancels the 3, I have 2x squared. Then I have 9, and the 7 is gone. F double prime of x, I get 3x squared minus 4x, and then the 9 is gone. Now I have g of x is 8e to the x squared minus 4x, so g prime of x. Remember to repeat 8e to the x squared. Derivative of x squared is 2x. Derivative of negative 4x is 4. Let's simplify that before we try the second derivative. I'm going to take 8 times 2 is 16x, e to the x squared minus 4. Now this time is interesting because now that I have this derivative of 16x e to the x squared, I need to use the product rule. So second derivative, g double prime of x, 16x is 16, I keep e to the x squared, plus keep 16x, e to the x squared, and derivative of x squared is 2x. What did I do here? I first took the derivative of 16x, and I got 16. I left the e to the x squared alone. Then remember you flip it. Now I leave 16x, and I take the derivative of e to the x squared. So there's my e to the x squared and the 2x. Careful with this. When I get the product rule, it does sneak up on you sometimes. We can simplify that. I have 16e to the x squared plus 2 times 16 is 32, x times x is x squared, e to the x squared. If you wanted to, you could factor out a 16 and an e to the x squared. Not really necessary yet. It'll come. Now I have h of x is x squared minus 5 to the power 7. So first time I take the derivative, I'm using the chain rule. The 7 comes down. I have x squared minus 5 to the power 6. X squared becomes 2x. We know we can make that look a little bit better. 7 times 2 is 14. Keep the x. I have x squared minus 5 to the 6. But what happened? Well, once again, that product rule came in from taking the derivative. So when I go to do the second derivative, I'm going to start with derivative 14x is 14. I have x squared minus 5 to the 6. Then I keep 14x. I bring the 6 down. I keep x squared minus 5. Now it's to the power 5, and I have a 2x. So this was the chain rule happening from the x squared minus 5 to the 6. There's my 6. Power goes down 1 and then back inside. Let's make that a little better. So I have 14 x squared minus 5 to the power 6 plus I have a 14, I have a 6, and I have a 2. 14 times 6 times 2 is 168. I have x times x is x squared. I have x squared minus 5 to the power 5. Let's practice factoring because I think it's helpful to see what do these things have in common. Well, they both have a 14, right? I can see a 14, I can see a 14, I can take that out. They both have an x squared minus 5. You're going to take out the smaller of the powers, so 6 and 5, 5 is smaller. So I look at what's left. Well, the 14 I took care of. X squared minus 5 was power 6, so I still have one left. 168 divided by 14 is going to be 12, but the x squared minus 5 is taken care of. You still have this x squared, so let's write that in. One more little step here. I have 14. I have x squared minus 5 to the power 5. Then in the parentheses, x squared and 12x squared is 13x squared minus 5. So this is a completely factored form, just looks a little bit better and it gets us set up for what's coming in the next part of the lecture. One more to show you. I have f of x is 3 over x squared plus 4. Hoping your immediate thought is let's turn that into a chain rule. So I can bring the power down. I get negative 3 x squared plus 4 to the negative 2. And then inside x squared plus 4 has a derivative of 2x. I want to rewrite that before I try the second derivative. So negative 3 times 2 is negative 6x. The x squared plus 4 to the negative 2, I'm going to put that back into the denominator. So this started as a quotient. I took the derivative, still a quotient. Now when I think about I have to do the second derivative, I do want to use the quotient rule because of the x in the numerator. So f double prime of x. I'm starting low, x squared plus 4 squared. d high is negative 6 minus high. Put that in parentheses because it has a negative. So it's minus parentheses negative 6x. There's my high. Then d low is a chain rule. So the 2 comes down from the power. X squared plus 4 now to the power 1. And then inside I have a 2x all over x squared plus 4 squared. Lots to do here to make it look a little bit better. I'm going to bring the negative 6 in front, make it x squared plus 4 squared. This negative right here, I'm going to make that a positive. I have 6 times 2 times 2, so 6 times 2 times 2, that would be 24. I have an x and an x, I'm going to call that x squared, and I have x squared plus 4 all over x squared plus 4 squared is power 4. So what I see that's particularly important to me is that I have x squared plus 4 and x squared plus 4 and x squared plus 4. Since it is everywhere, I could factor it out and get rid of one power. So now if I take out the x squared plus 4, just one power of it, I still have a negative 6 times x squared plus 4. I have 24x squared. And on the bottom, I have x squared plus 4 to the 4th. I can cancel one power from the top with one power from the bottom. So what's left now? I have this negative 6 I can multiply out. I have negative 6x squared minus 24 plus 24x squared over x squared plus 4 to the power 3. I can combine the negative 6x squared with the 24x squared, so f double prime of x. 24 minus 6 gives me 18x squared minus 24 over x squared plus 4 to the power 3. Eventually, what are we going to do? We're going to take the second derivative and set it equal to 0. So when you're looking at all the steps I did for simplification and thinking they're a little extra, they're also a little necessary. The only way we're going to be able to get it set equal to 0 is if we can simplify and make it look a lot better.